Hello, I'm Guido Kirsten, Principal Scientist at Chemical Computing Group. In this video, I will show you the Combinatorial Library Enumerator, or CLE. It allows you to sketch and refine reactions in real time, search chemical reagent catalogs on the fly, and apply interactive filters to refine reagent and product lists. Let's see it in action. The interface has two sections. In the top part you can sketch and visualize the reaction, and in the bottom section the reagent and product lists will be displayed. To get started, we need a reaction. We could either sketch one or select one from the list of standard reactions. Most of the standard reactions you will know from your organic chemistry classes. At the first glance it looks like all of them are just two-component reactions, but if I enter, for example, UGI in the search box, I get the UGI 4-component reaction. So the standard reactions range from simple two-component to complex multi-component reactions. If your desired reaction is not in the list, you can use a sketcher to create it from scratch or modify an existing reaction. Let's say you have a scaffold that you would like to decorate. First, we have to sketch the scaffold. I will load it from a file to save a bit of time. And I will go for quinazoline scaffold.mo, that's the one, and I will import it into the sketcher. Let me increase the size so that you can see it. We are going to do a Schotten-Baumann-like reaction with a sulfonic acid halide as one reagent and an amine as a second reagent. So the first thing I have to do is to copy over the scaffold from the product side of the reaction to the educt side. And now I can sketch the amine and modify the product accordingly. And look at the bottom part of the screen. Mo is already screening the reagent libraries for matching compounds and displaying them as list. And Mo has also already started the product enumeration. Which reagent catalogs are screened is user configurable. You can adjust the settings in the main hamburger menu. Here you can upload CSV, MDB or SDF files and define filters for each of them. The first thing I always do after sketching the reaction is looking at the initial preview of the reagents and products to check if there is any problem with my reaction. Oops, all the products are identical and do not contain any atom of the first educt. Stupid me, I forgot the atom mapping. I can do the mapping manually or automatically. When I got, for example, a reaction with a bidentate, I prefer to do the mapping manually, but in this case automatic is just fine. Mo has already restarted the product search and is updating the lists. When you look at the product list, you see that for each product the functional groups contained are listed and some properties are calculated. There's also a field that annotates if the combination of educts would lead to a mixture. So let's just have a look whether we can spot some problem here. So why is it considering this as an educt? Oh, it's also considering tertiary amines as reaction centers, but Schotten-Baumann does not work for tertiary amines. So we need to add a query annotation to our reaction to exclude them. So let me select the nitrogen and open the query annotation panel. The query annotation panel has two tabs. One for atom properties like bond, hydrogen count, ring membership and some wildcards, and the bond tab to specify the required bond order and type. Let me set the heavy atom count for the nitrogen to 1, and that will give us primary amines only, regardless whether they are protonated or not. Now let's have a look at the updated hit list for reagent number 1. Each row shows the structure, the functional groups that have been detected, supplier information and some properties that I can use for filtering. Chemical groups and suppliers I can filter directly from the list view, but also from the filter pane on the left. This pane also has a list of protective groups, For example, if I have a functional group that would decomposite under the reaction conditions, I can search for protected reagents directly. Histograms for the properties are calculated, and I can use them to restrict the property range of the educts. We have found more than 4,000 amines, and there are some that are not really useful. As we are looking for just a small modification to our scaffold, let's use the property filters to get a more suitable selection. I will set the molecular weight limit to 150. I can either use the text boxes or the sliders. The heavy atom count I will reduce to 15, the number of heteroatoms to 5, and the rotatable bond count also down to 5. And that leaves us with a bit more than 500 reagents. That's more reasonable, but I still see some candidates I would like to remove. So, for example, I don't want lithium salts, I don't want alkenyls. So I can remove the lithium salts by just clicking on the checkbox, and then the compound will be removed from the list automatically. To filter alkenyls now, as the compound is not in the list anymore, I have to use the functional groups on the left. So let's scroll to alkenyl, and I can exclude them here. Regardless where I click on the checkbox, both lists are synchronized. We are also not doing a Suzuki coupling, so I can remove the boron and boronic acid containing compounds. When we discuss the tertiary amines as educts, I used the query annotation to remove them, but I could also have used the chemical groups filter. So if I look at the chemical groups and scroll up, I will find the secondary amines here and also the tertiary amines, and by activating the checkboxes, they will be excluded from the educt list. And now we see the next problem. Some educts contain more than one amine, so we would have to protect one of them or filter them out. And to achieve that, I will use the ambiguity filters, and I will filter out the symmetric and the asymmetric compounds. And that is already fine-grained filtering, but I can go even further. I can exclude individual compounds by clicking on the X, or make them a favorite by clicking on the star. So let me just remove this one. Now it's time to check what we have got. So I will switch to the product, and the product page shows me the product and the educts as well as the functional groups and the properties. On the left, I have filters again, where I can define my design goals. And with the group filters, I can exclude reagents with a certain functional group, but what can be done when I require a certain functional group. In these cases, I can add a disconnected substructure to my reagent query. And let's make a cyclopropyl group a required feature of the first educt. So what I do in the sketcher is I will just draw a cyclopropyl on the educt side, and then I will select the first educt in the cyclopropyl and merge them together. Now I have to update the atom mapping. And what I've done now is I told Mo that there has to be a 3-membered ring somewhere in the first reagent. I don't specify the length of the linker between the amine and the ring. And I have also updated the atom mapping. So that gave me 5 amines for reagent 1, and that will also give me 5 products. That's a very reasonable number. So I'm happy with that, and I can export the results along with the reagent IDs, and get them synthesized. So I would like to export reagent 1, reagent 2 is constant, and the products I also don't need to export. So here I can choose to export them as CSV and SCF, that's fine for me. So I just click on the export button and can get the compounds ordered. Now that is just the first synthesis step. Let's assume that the next step would be a Gabriel reaction, and it would be very tedious if we would have to do everything again for each reaction step. Instead, you can process it as a multi-component reaction in one go. So let's modify our sketch reactions by adding the benzene halide that attacks the imide nitrogen. So I will just sketch the benzene halide. I have to specify the allowed atoms, chlorine, bromine and iodine. Fluorine will not react for this atom over here, and here I have to specify that we will need 2 hydrogens for the reaction, and I have to modify the product accordingly. So that will attack the imide nitrogen and update the atom mapping again. As you can see, Mo has added a third tab for the third reagent automatically. And let's have a look at the hits. It seems that Suzuki coupling is very popular, so we found a lot of boronic esters. So let's again remove them from the list. I also would like to remove symmetric compounds, as we don't want oligo or poly products in our list. And I will also set the educt filter. So let's say the molecular weight, let's allow a little bit more because we have the benzene ring, 250. Heavy atom count, again 15. And number of heteroatoms 5. Rotatable bond count, again down to 5. Now let's have a look at the products. Okay, that looks fine for me. I'm happy with that. So let's summarize. In this video, I've shown you the combinatorial library enumerator, which allows you to sketch simple and multi-component reactions, preview hit lists to refine reactions on the fly, include substructures in the search, and filter the competing chemistries and mixtures. All of these aims to streamline the process of building combinatorial libraries and deciding which reagents to purchase. If you have any questions, please contact us at support@cancomp.com.